So you might want to ask this sort of simple kind of question from a molecule by molecule perspective. Why is it that water tends to have these different values for Kw? Well, if you think about it, you're talking about the difference between cold water and hot water and what's going on. When you have cold water, you've got this water molecule here. It's got less energy sitting inside it. That means there's less energy that goes into the kind of wiggling that occurs that allows a proton to separate from an H plus and an OH minus. So the fraction of the H plus and OH minus that dissociate is going to be relatively small. On the other hand, as you start to dump heat into the system, then you start to put more and more energy into your water molecules, and they tend to be doing more and more moving, and the next thing you know, you have more dissociation occurring. And so a higher percentage of the water has dissociated at that higher temperature. So this is a very simple kind of way of explaining how it is as I put more energy into a system, I tend to favor the reaction moving to the right to promote more dissociation. And that's why it is that I see this literally near 3 order of magnitude difference in the amount of dissociation that occurs. 1.5 orders of magnitude in actual concentration as I go from having a cup of cold water to a cup of hot water in terms of how much proton and hydroxide is being formed.